Alright, this problem I want to find the torque about 0.0 from the 50 Newton force. What I'll do first is I'll break the 50 newtons up into its parts. So I'll have a y component and an x component. And I have 60 degrees with the x. My x component then touches the angle, so I'll have 50 newtons times the cosine of 60 degrees. And my y, 50 newtons sine 60 degrees. So this will be 25 newtons. And the other one will be something else. .30. Once my pen starts working again. Whoops. 43.30. Now what I need to do is I need to find my distances. So what I really need this will be my dy, and then all of this is my dx. Well, I have one segment that's at an angle, 200 millimeters. If I find that y and that x, 45 degrees here, I can add the y component will be my dy, so maybe I'll just go ahead and write that as that'll be my dy, and then this one plus 100 millimeters, the x will give me my dx, distance in the x direction. So for the x component here, I have 200 millimeters times the cosine of 45 degrees, and for my distance y, I have 200 millimeters sine 45. Now since we're 45 degrees, both of those end up being the same. And so I'll just type one of them in. .42. Oops, those are millimeters. What that means is, okay, dy, that's the part I need. That's my y distance for my force. My distance for the x then is 100 millimeters plus 141.42 millimeters, or 241.42 millimeters. My torque equation then, about 0.0, is force x distance y plus force y distance x. My force x, these were forces up here, is 25 newtons. My distance y, 141.42 millimeters. My force y, 43. And my distance x, 241.42. Alright, that'll give me the magnitude, or well, of each component there anyway. Now I need to assign the direction. If I go back up here, and I'll choose red this time, we'll make it a little bit thicker. It's equivalent to saying I have force y, force x. From my y component, it's going to tend to rotate like this. From the x component, I'm going to tend to get rotation like this. So the x rotation is going to tend to be positive. The y rotation is going to tend to be negative. So the y rotation here is negative and the x rotation is positive. Go back to my pin, and then now I can put that in my calculator. Okay. Alright, so then my final answer is a negative 6,917.99 Newton millimeters. And since I was only interested in the torque about 0.0, I'm done with the problem.